All right, welcome back. Let us continue from the previous problem. So on the previous problem, we were given that we have an object that is accelerating to the left with an acceleration of 2 meters per second or 2 meters per second squared. And we were told that there was a force that is applied on this object of 20 newtons. And once it is moving on the surface, there was going to be a frictional force, and we determined the frictional force in the previous video, that it was 4 newtons, and it was going in the opposite direction of the applied force. So in this video, we are told to determine the coefficient of kinetic friction. So based on all the information that we have right now, we have to first know the equation that determines the coefficient of kinetic friction. So the equation, it says it is the frictional force of an object, or the frictional force that is experienced by the object. It is equals to the coefficient of the kinetic friction, and it is multiplied by the normal force. Right, so the normal force is the one that I spoke about it in the previous video. It is upward on this object, and it is in the opposite direction of the weight, or the force of gravity. Right, so looking at this equation, we do have the frictional force that we determined, which was 4 newtons. The kinetic friction, we are looking for it. What about the normal force? Are we given any values of the normal force? In this case, it is no. So we have to determine the normal force before we can continue to determine the kinetic, or the coefficient of the kinetic friction. How do we do that? We have to know first. I've mentioned that the normal force and the gravitational force, or the weight, they are equal. Right, I've mentioned that it is the same value, just that they are in the opposite directions. So if they are equal, then I can say the normal force, it is equals to the force due to gravity. Right, so the force due to gravity, it is the weight, as I've mentioned, and the equation for the weight, it says it is the mass of an object that is multiplied by the gravitation, or the acceleration due to gravitation or gravity. Right, so we do know this value of the acceleration due to gravity, which is a constant value of 9.8 meters per second squared. Right, so based on that information, and we were already given the mass of this object, which is 8, we can just say 8 kilograms. We multiply that with 9.8. Right, and how much do we get? I believe we will get something like 78.4 newtons, which is our normal force. So since now we have the normal force, which is N in this case, so now we can, from this equation, we can solve for the coefficient of kinetic friction. So I'll just rearrange this equation and put the coefficient of the kinetic friction as the subject of the formula. If I do that, I'm going to have friction, and then we divide it by the normal force. Okay, so moving forward, the friction, I already have the friction, it was 4 newtons, right? And then the normal force I just determined, which was 78.4 newtons, right? So if you notice, the numerator has a unit of 4 newtons, which is, it is a force, it is newtons, and also the denominator is a unit of newtons. So the newtons will cancel each other, So which means the value that we get here, it is going to be just a value without units. So what is 4 divided by 78.4? So punching on the calculator, we get that the value is going to be 0.05. That is our coefficient of kinetic friction, and that's how we determine it.